A very good morning to one and all. This is J. Anusha working as lecturer under Department of Technical Education, Telangana. I am working at SS Government Polytechnic, Zahirabad in general section, and the subject what I am dealing with is applied physics for first year second semester students with the subject code 18 common 203F. And the topic what we are going to discuss is electronics, which is sixth chapter from our syllabus. Now from this chapter in today's class we are going to learn about classification of materials depending upon forbidden gap. Now to understand this, we are going to use a small PowerPoint presentation, and with the help of some photographs we are going to see how materials are classified. The main objective of today's class is, by completing this topic, you will be able to understand how materials are classified on the basis of forbidden gap and what is the concept of Fermi level. Now, depending upon the forbidden gap, which we have seen in the previous class, that is the gap between valence band and conduction band. Now, depending upon this forbidden gap, the materials are classified into three types: insulators, semiconductors, and conductors. In general, we know that insulators are the materials which does not allow flow of currents. Semiconductors, they partially allow the flow of current, and conductors, they allow flow of current very highly. Now, depending upon forbidden gap, let us see how these materials are defined. So before moving on to definitions, here we can see a energy band diagram for insulator, semiconductor, and conductor. Now in all the three diagrams, for insulator we can see valence band and conduction band. There is a forbidden gap which is greater than 5 electron volt. In valence band, there are valence electrons which are bound to nucleus, and in conduction band we are having free electrons which are which can freely move. Now for semiconductors, the forbidden gap is not that much as for insulator, and for conductor we can see forbidden energy gap is not there. Both the bands overlap with each other. So with the help of the small picture, we can define all these three substances separately. First, we'll see what are insulators. Now, what are insulators? Insulators are those materials in which forbidden gap between valence band and conduction band is very high. As the gap is very high, we can see what happens, or what happens with valence electrons and free electrons. Now forbidden energy gap is more than 5 electron volt. Now as the gap is high, we can say that they do not allow the passage of electric current through them. Now in terms of energy bands, the insulators have full valence band and an empty conduction band. and there is large energy gap between conduction and valence bands. Now here are some examples for insulators: wood, glass, rubber, cotton, air and diamond. These are some substances which are known as insulators. The only electrons in the conduction band participate in electrical conductivity. Therefore, there is no electric flow in insulators. Why there is no electric flow in insulators? Because conduction band is empty. There are no electrons in conduction band to participate in electrical conductivity. Now, in order to move electrons from valence band to conduction band, we need some external energy which is equal to forbidden gap. Now, as we know that forbidden gap is very high, we need high external energy to move electrons from valence band to conduction band. Now, in insulators, this is practically impossible since forbidden gap is very high and the electrons in valence band are completely filled. Now, these completely filled electrons which are in valence band, they need to jump from valence band to conduction band for electrical conductivity, which is impossible because forbidden gap is very high. Next type of materials or substances are semiconductors. Semiconductors are those materials in which forbidden gap between valence band and conduction band is very small. It is of 1 electron volt. So these materials have electrical conductivity between that of conductors and insulators. So that's what I said. I used a word, their conductivity is partial, that is between conductors and insulators. Now here are some examples of semiconductors. They are like silicon, germanium, gallium and graphite. Now at room temperature for silicon, forbidden gap is of 1.12 electron volt. For germanium it is 0.67 electron volt, which is very less than 1. I mean it is very small. For gallium it is 1.42 electron volt. When we compare these three, for germanium, as forbidden gap is very small, it may have electrical conductivity high when compared with silicon and gallium. Since the gap between valence band and conduction band is very small, even at room temperature, the electron which are in valence band, they gain energy to jump from valence band to conduction band, and hence they act as conductors at room temperature. In terms of energy bands, the semiconductors have almost an empty conduction band, almost filled valence band, very narrow energy gap between two bands. So at low temperature, they behave like an insulator. Now next type of materials are conductors. Conductors are those materials in which valence band and conduction band are overlapped. Overlapped means there is no forbidden gap between them. So as there is no energy gap, they easily allow flow of electric current through them. Now here are some examples: aluminium, copper, gold, platinum, silver, etc. These materials are very rich in electrical conductivity. In terms of energy band, the valence and conduction bands overlap each other. Due to this overlapping, electrons are available in the conduction band to participate in electrical conductivity. So as there is no gap, the valence electrons which are present in valence band, they easily jump to conduction band and they become free electrons so that they move freely to produce electrical conductivity. So therefore its electrical resistivity is very low. Now here we can see a line which is named as Fermi level. It is a level. In case of metal, it is in between valence band and conduction band. Now let us see, or let us define what is this Fermi level. The highest energy level that an electron can occupy at the absolute zero temperature. Absolute zero temperature is nothing but 0 Kelvin. At 0 Kelvin, the highest energy level that an electron can occupy is known as Fermi level. In general, it lies between valence band and conduction band, but it may change its position by a change in temperature. Here is another definition of Fermi level. It is defined as the energy level which corresponds to the center of gravity of conduction electrons and holes, which are weighted according to their energies. According to their energies, if the weight of electrons and holes, where it is high, the Fermi level is represented there. So it is center of gravity of conduction electrons and holes weight according to their energies. So here we can see in semiconductors, the probability of occupation of energy levels in the conduction band and valence band are equal. Therefore, the Fermi level for intrinsic semiconductor, which is pure semiconductor, later we'll see what are intrinsic semiconductors. It lies exactly in the middle of forbidden gap. So Fermi level of semiconductor is given by EF is equals to EC plus EV by 2, where EF is energy of Fermi level, EC is the average energy of conduction band, and EV is average energy of valence band. So let us summarize what we have seen in today's class. We have seen, or we discussed about the classification of materials on the basis of forbidden gap. Depending upon forbidden gap, the materials are classified into 3 types that we have seen: insulators, semiconductors and conductors. For insulators, forbidden gap is very high. For semiconductors, it is very small. And for conductors, there is no gap between valence band and conduction band. And also we have seen the concept of Fermi level. So a material with more than 5 electron volt forbidden gap, more, forbidden gap is more. So is it for conductor, insulator, semiconductor or an isolated atom? It is for insulator. Which of the following is not a semiconductor? Silicon, gallium, germanium, aluminium. So aluminium is not a semiconductor. Energy gap is overlapped between valence band and conduction band is it in insulators, conductors, semiconductors or superconductors? It is in conductors. Consider the energy level diagram of an intrinsic semiconductor. The Fermi level lies in valence band, forbidden band, conduction band. It can be at any of the above locations depending upon the doping concentration and temperature. For pure semiconductors, it is in forbidden band. Frequently asked questions about the topics what we discussed here is, you may get the question like to define the terms on the basis of forbidden gap. So we need to define insulators, conductors and semiconductors. And also you may get a question to explain the concept of Fermi level by drawing Fermi levels of insulated semiconductors and conductors. So for this question, you need to draw this diagram. You need to represent where the Fermi level is lying for metal, semiconductor and insulators, and you need to define what is Fermi level. So this is what we discussed about the concept of classification of materials depending upon forbidden gap. On this classification, we can see that there is a highest energy level occupied by electron, which is known as Fermi level. So I hope it is clear for you. Thank you so much for listening this class.